Industrial panic dictated the design. During the Second World War, Germany produced more tank destroyers than actual tanks. Almost none of these projects existed on paper before the first shots. They were desperate reactions. How did the most feared vehicles of the Reich begin? From a vacuum of planning. The process was mechanical chaos. A new Soviet or Allied tank appears on the horizon. It is invulnerable to standard shells. Berlin panics. Engineers seized the largest available gun and bolted onto any chassis found in the warehouse. The results were erratic. One plant delivered high-tech monsters. Another rolled out improvised junk held together by thin steel plates and optimism. Soldiers occupied these machines with varying degrees of dread. In the early stages, crews hid behind flimsy gun shields. These open-topped hybrids offered zero protection from shrapnel or snipers. These were not weapons of conquest. They were mobile bandages for a bleeding front line. Logistics followed the same frantic rhythm. Factories stripped chassis from obsolete tanks. They emptied captured depots for foreign cannons. Production numbers climbed, but the variety of parts created a maintenance nightmare. Some solutions proved brilliant, others were engineering disasters. Frequently, they were both. This technical evolution followed a jagged trajectory from field improvisations to specialized heavy steel. It started with a specific failure. A gap in the defense required an immediate fix. This mistake produced the first successful self-propelled gun. The technical root to the tank destroyer lie in the mud of the Great War. This concept of assault artillery emerged directly from the blood-soaked trenches of the Western Front. Every major offensive hit the same wall. Infantry would breach the first line. They would take the second. Then they stalled. The artillery providing their cover could not move forward. Standard field guns, like the 7.7-centimeter FK-16, weighed over 1,300 kilograms. Horses could not pull them. The animals panicked. Their hooves slipped in the waist-deep sludge. Artillery wheels sank into a lunar landscape of shell craters and jagged steel. The infantry moved into the open. The guns stayed a mile behind. Communication lines snapped. Soldiers faced machine guns without a single heavy barrel to support them. They died in the thousands. German officers spent the interwar years analyzing this slaughter. They needed a solution for the next conflict. The conclusion was physical. The infantry required its own armored, mobile, direct-fire weapon. A gun that could roll into the fire alongside the boots. While developing the mechanics of blitzkrieg, the High Command formalized this doctrine. They called it Sturmartillerie. These tactical requirements shifted from paper to the design bureau. Officers formed the foundations for a new class of armored vehicle. By 1939, these blueprints had hardened into a rigid hierarchy of 3 armored machines. The system was surgical. 2 distinct roles, 1 goal, total battlefield dominance. The Panzer III was the dedicated predator. Its mission was armor-to-armor combat. It carried the 37mm KWK-36, a high-velocity needle designed to punch through any contemporary tank. Engineers planned for the future. They built the turret ring oversized. It was a deliberate gap, ready to house a 50mm cannon when the enemy caught up. Beside it rolled the Panzer IV. The Germans called it the accompanying vehicle. It wasn't there to fight tanks. It was a mobile sledgehammer for the infantry. Its short-barreled 75mm gun functioned as a tracked howitzer. It lobbed high-explosive shells into bunkers and machine gun nests. Then came the outlier, the Sturmgeschütz III. The Stug III used the Panzer III chassis but discarded the turret for a low-armored casemate. It carried the same blunt 75mm gun as the Panzer IV. 2 machines, 1 task, infantry support. How did the crews experience the difference? The Panzer IV commander scanned the horizon and swung his turret 360 degrees to crush a flank attack. Inside the Stug III, the reality was cramped and suffocating. The air stayed thick with the smell of spent cordite. The gun had a traverse of only 12 degrees. To aim, the driver had to kick the levers and pivot the entire 23-ton hull on its tracks. This constant grinding shredded the transmission and wore the steel teeth of the drive sprockets to nothing. The trade-off was survival. The Stug was cheaper, lower, and carried thicker frontal plates for the same weight. It was a ghost in the tree line. This was the perfect pre-war doctrine. It was a logical hierarchy built for a world of thin armor and light calibers. How long did this ideal system survive? Only 8 months. The ideal system collapsed in May 1940. France became a graveyard for German tactical theory. The Char B-1, Jura, emerged from the tree line. A German anti-tank crew slammed a 37mm shell into the breach. Fire. A direct hit on the hull. The round shattered, sending a shower of sparks across the cast armor. The French tank didn't slow down. It kept crawling forward. Another hit. Another. 140 shells struck the Jura. Not a single one penetrated the 60mm frontal plate. Was the weapon flawed? The numbers provided a cold answer. The Pak-36 could only penetrate 29mm of armor at 500 meters. It was half of what was required. Against the British Matilda II, the situation was worse. Its 78mm frontal skin was a physical impossibility for the German gun. The crews gave their weapon a new name, the door knocker. It knocked politely, but no one opened. Panic forced improvisation. Commanders ordered 88mm flak guns to the front line. These massive anti-aircraft cannons were the only tools capable of cracking Allied steel. But they were scarce. An 88mm gun weighed 7 tons. It was a giant, difficult to hide, and slow to move. It was never designed to hunt tanks in the mud of a breakthrough. A solution was needed immediately. While heavy anti-aircraft guns saved the infantry, engineers scrambled to assemble a makeshift armored hybrid. They needed a solution before the invasion of France even began. The standard 37mm Pak-36 was already a failure against heavy armor. Its successor, the 5cm Pak-38, remained stuck in development. Mass production was months away. Planners turned to the scrap heap. They took the chassis of the Panzer I, a light tank already obsolete and armed only with machine guns. They stripped the turret. In its place, they bolted a captured Czechoslovakian 4.7cm anti-tank gun onto a pedestal mount. This was the Panzerjäger I. It was Germany's first purpose-built tank destroyer, a Frankenstein of old tracks and foreign steel. The machine was a desperate compromise. The driver sat inside the hull, but the gunner and commander stood in an open-topped compartment. They were exposed from the waist up. A thin 14mm steel shield was their only protection. It stopped rifle bullets, nothing else. Any high-explosive fragment or heavy machine gun burst shredded the crew instantly. For gunners tired of watching their shells bounce off French armor, the new gun was a temporary relief. But the marriage of an old tank and a captured cannon had limits. The 4.7cm shell lost its lethality quickly. It still struggled to penetrate heavy plates at any distance beyond 500 meters. In the summer of 1941, the Panzerjäger I crews drove into a mechanical nightmare. Operation Barbarossa was supposed to be a repeat of France. German intelligence expected a few heavy tanks. They predicted air power and tactics would bridge the gap in firepower. They were wrong. Why did the new 50mm shells bounce off the armor? An angle of 60 degrees changed the laws of physics. On the second day of the invasion, the front line shattered. The Soviet T-34 appeared in numbers the Wehrmacht hadn't imagined. Its 45mm frontal plate wasn't just steel. Sloped at 60 degrees, it provided an effective thickness of 90mm. This surpassed the penetration of the German 50mm gun nearly twofold. At ranges beyond 500 meters, rounds simply screamed into the sky as ricochets. The KV-1 was a moving fortress. 75mm of armor protected every side. The 50mm gun, the pride of the Panzer III, hit the KV-1 like a toy. It was useless from any angle. The visual on the ground was a slaughter. A 50mm shell strikes the T-34's glacis. It sparks and deflects. The Soviet tank doesn't slow down. It surges toward the anti-tank battery. The German crew scrambles. Metal groans as the tracks crush the gun carriage into the mud. The aftermath left a specific image: twisted, blackened barrels pressed deep into the earth. The smell of scorched diesel and ozone hung over the flattened batteries. Soviet crews drove over the guns, then turned their machine guns on the survivors. The anti-tank doctrine of the Reich had collapsed in 48 hours. To stop a single tank, German batteries had to score dozens of hits. 30. The Soviet armor of the T-34 turned the 50mm gun of the Panzer III into a useless piece of metal. It was a collision with a physical wall. 1,520 millimeters. That was the exact diameter of the Panzer III turret ring. This number became a death sentence for the machine. The geometry of the hull was frozen. It physically could not absorb the massive breech and recoil mechanisms of the new 75mm Pak-40 gun. By 1942, the Panzer III was a dead end. Engineers attempted a desperate roll swap. The tank received the short-barreled 75mm howitzer that the Panzer IV was discarding. It transitioned from a hunter to an infantry support vehicle. The proven and reliable chassis survived only as the foundation for the Stug III. By 1943, the assembly lines for the tank version stopped forever. The Panzer IV held the only key to survival: a larger turret ring. It was designed as a heavier platform from the start. This extra space allowed the installation of the vehicle-mounted 75mm Pak-40. The power shift was absolute. German crews could now penetrate the T-34 frontally from over 1,000 meters. The Panzer IV became the industrial workhorse, the closest thing to a main battle tank in the war. But the upgrade cycle was too slow for the collapsing front. High Command again plugged holes with scarce 88mm flak guns. It was not enough. The crisis demanded immediate volume. Engineers diverted every available Panzer IV chassis to meet the new specialized requirements. 88mm is not a universal weapon. It is a logistical death trap. The brass casing for the Tiger I was 571mm long. This specific round, the 88 by 571, physically failed to fit into the breeches of the new tank destroyers. The bore diameter was identical. The reality was a fractured system. Germany operated two entirely different 88mm ecosystems. One traced its lineage to the Flak 18 anti-aircraft gun. Engineers adapted this weapon for the Tiger I, designating it the KWK-36. A loader in a Tiger I reaches for a shell. He feels the weight of the massive brass cylinder. He slams the 571mm casing into the breech. The heavy metallic clang echoes in the turret. He sees the distinct factory markings painted on the base of the heavy brass. These markings were the only thing preventing a fatal mistake. Supply columns faced a nightmare. A battery of Pak-43 guns waiting for resupply could receive crates of Tiger I ammunition. The shells looked the same. The caliber was 88mm, but the Pak-43 used a completely different, more powerful cartridge. Delivering Flak 18 or KWK-36 rounds to a Nashorn crew rendered the vehicle a hollow steel box. This was a conflict of two incompatible standards. One caliber, two distinct worlds of ammunition, 3 kilometers of open, unobstructed steppe, a distance where a tank looks like a grain of sand. What do you do when enemy armor grows thicker, but your 75mm shell loses its lethality at 1,500 meters? You find a bigger caliber. While engineers measured brass casings in millimeters, crews faced a lethal geometry. The horizon on the Eastern Front had pushed visual contact to 3,000 meters. At that range, the standard Pak-40 was effectively blind. Optical rangefinders failed. Heat haze and dust clouds over the Ukrainian soil created critical margins of error. Precision vanished. The 75mm L-48 remained the workhorse. It killed T-34s reliably at medium range. It could crack a KV-1 if the gunner waited. But beyond 1,500 meters, physics took over. Penetration dropped sharply. Accuracy became a gamble. German intelligence already reported heavier Soviet monsters on the assembly lines. The 75mm gun had reached its ceiling. To survive the step, the Wehrmacht needed to strike from the horizon. Frontline commanders filed urgent requests for high-velocity weapons capable of killing at 3 kilometers. The Wehrmacht found the answer in a weapon of the Spanish Civil War, the legendary 88. To kill at 3 kilometers, engineers refined the Flak 41 into a dedicated tank killer, the 8.8-centimeter Pak 43 L71. The ballistics were absolute, a muzzle velocity exceeding 1,000 meters per second. At a range of 1,000 meters, its tungsten core rounds punched through 190 millimeters of rolled steel. This was the thickness of a Great War heavy cruiser's belt armor. Now, a single shell delivered that power to a tank's turret. But the physics of destruction demanded a brutal price in weight. The gun weighed over 4 tons. In the mud of the Eastern Front, the heavy tractor roared, straining against the steel mass. The crew leaped from the half-track. Under incoming fire, they struggled to unlock the mounts. Shovels hit frozen earth, muscles tore. The massive gun shield offered protection, but its size was a curse. Metal screamed against metal. The ungreased hinges of the shield emitted a high-pitched, agonizing screech as the crew forced it into position. They were moving a mountain while the enemy closed the distance. Frontline soldiers watched the silhouette against the horizon and gave it a mocking nickname: the barn door. It was the finest anti-tank weapon on Earth. It was also a tactical anchor. To save the weapon, they had to make it move. This birthed a chaotic family of machines, born from industrial desperation and political infighting. The weight of the steel had become a death sentence for the men tasked to move it. 4.4. To move heavy guns from a dead stop, German factories launched a mass conversion of 1,300 captured Soviet field guns and hundreds of French tractors. This was industrial Frankenstein. The ingredients were simple: obsolete hulls, powerful cannons, and total desperation. The first component was the Soviet 76mm gun. Engineers rechambered these trophies to fire the high-velocity Pak 40 cartridge. The result was a weapon capable of destroying any tank in the world at standard combat ranges. The second component was the chassis. Anything with tracks would do. 300 captured French Lorraine tractors became the foundation. They mounted the gun in a thin, open-topped box with a maximum of 12 millimeters of armor. They called it the Martyr I. How to protect a crew in an open fighting compartment during urban combat? Absolutely halfway. There was no protection. A grenade dropped from a second-story window turned the steel box into a grave. The Martyr II followed, utilizing the obsolete Panzer II chassis. The Martyr III, the most numerous variant, relied on the Czech Panzer 38T. These machines were a massive improvement over the useless 37mm door knockers. They could kill, but they couldn't survive. The design was a suicide pact. The armor measured 10 to 15 millimeters. It was enough for small arms, but nothing more. On the flat, infinite steppes of the East, these tall silhouettes were visible for miles. The air inside the compartment stayed cold. Soviet anti-tank rifles fired. The heavy bullets struck the thin plating with a high-pitched metallic crack. They punched through the 12mm walls like tissue paper. Every near miss from a mortar showered the crew with red-hot steel. One random splinter was enough. Death from a stray fragment. The suicidal concept of the 15mm open hull reached its peak with the mobilization of the monstrous Pak 43. This emergency solution became the Nashorn. The silhouette sat high, a massive steel box visible from miles away. The crew stood on an open platform. To the enemy, they were targets. To the Reich, they were just a carriage for a gun. The chassis was an industrial hybrid. Engineers took the Geschützwagen 3-4, a platform merging parts from both the Panzer III and Panzer IV. They bolted the 88mm Pak 43 on top. Hitler initially named it the Hornis, or Hornet. He later changed it to Nashorn, the rhinoceros. Was it a tank? No, it was a compromise. The armor on the superstructure measured only 10 to 15 millimeters. A hand grenade could clear the entire fighting compartment. Yet, This fragile box carried the most lethal weapon of the war. The gunner adjusted the optics. He tracked a Soviet T-34 at a distance of 4,000 meters. 4 kilometers of open field. He pulled the trigger. The Pak-43 roared. The thin steel walls of the cabin vibrated violently from the muzzle blast. The shell crossed the distance in seconds. 1 hit, 1 kill. How could a crew feel safe in a machine that could kill at 4 kilometers, but died from a single stray fragment? They couldn't. They operated in a state of constant psychological friction. They held the power of a god in a hull made of cardboard. The Nashorn proved its lethality even in the ruins of the collapsing Reich. In March 1945, in the streets of Cologne, a Nashorn encountered the pride of the American armored forces. A single shot at close range destroyed the only M26 Pershing deployed in Europe at that time. While the Nashorn crews gambled their lives in open-topped boxes, German industry delivered 10,000 fully enclosed Stug 3 assault guns. Why did a turretless vehicle destroy more tanks than the legendary Tigers? The secret lay in a silhouette measuring exactly 2.16 meters. This height made the machine mathematically twice as hard to spot in the brush than a standard tank. The Germans adapted the 7.5 centimeter Stuck 40 gun for a fixed casemate. It used modified cartridges for easier handling in the cramped interior. By removing the heavy turret, engineers applied thicker frontal armor plates without increasing the total weight. This solid face had no weak rotation rings. The tactical shift was immediate. In the vastness of the Eastern Front, the Stug 3 became the ultimate ambush predator. More than 10,000 units rolled off the assembly lines. By 1945, these low-profile killers claimed more kills than the Panther and Tiger fleets combined. They struck from hidden positions, systematically erasing Soviet armored columns from the map. German engineering pragmatism vanished when Ferdinand Porsche tried to save 91 rejected heavy tank chassis. The ambition was simple. If the Nashorn was too thin, its successor would be a rolling fortress. 2 giants, Henschel and Porsche, fought for the Tiger tank contract. Henschel chose tradition. Porsche chose a technical revolution. His design used a gasoline-electric hybrid drivetrain. Gasoline engines roared, spinning massive generators. These generators sent high-voltage current to electric motors. Only then did the tracks move. The air inside the hull filled with a high, strained whine. It was the sound of electric motors overheating under 70 tons of steel. Complexity became a death sentence. The system was fragile, prone to internal fires, and impossible to repair under fire. Porsche was arrogant. He built 91 hulls before the contract was even signed. Scrapping them was unthinkable for a nation at war. The hulls became the foundation for a new monster, the Ferdinand tank destroyer. Engineers bolted a massive armored box onto the rear. They armed it with the same 88mm Pak-43 as the Nashorn. But this time, the crew sat behind a wall of invincibility. Workers hurried to meet the deadline for the summer offensive at Kursk in 1943. The machine was an industrial Frankenstein. To make it unkillable, crews welded additional 100mm armor plates directly onto the existing hull. The weight spiraled to 70 tons. Standard railroad bridges groaned and snapped. Special heavy-duty platforms were the only way to move the beast to the front. On paper, the Ferdinand was a god of war. No Allied gun in 1943 could dent its face. It possessed the ultimate reach and the ultimate shield. It was a bunker on tracks, born from the pride of a single designer. 200. The gasoline-electric drivetrain failed the Tiger trials. It failed the Russian steppe even harder. 70 tons of steel turned into a static oven under the July sun. The dual engines screamed. The generators overheated. Porsche's ambitious nerve system was melting from the inside. 200 millimeters of frontal armor made it a rolling fortress, but the fortress was blind. Engineers forgot the most basic requirement, a machine gun. Soviet infantry simply walked up to the blind spots. The crew sat in a multi-million-mark bunker, listening to the clatter of magnetic mines hitting the hull. Desperation took over. Men cracked open the heavy hatches. They leaned out into the dust and heat, firing Luger pistols at soldiers ducking under the main gun's traverse. The most protected tank crews in the world were fighting like common street thugs. Logistics became a death sentence. Eastern Europe's wooden bridges had a limit of 65 tons. The Ferdinand weighed 70. Every crossing was a gamble with gravity. If the timber snapped or the track sank into the soft Russian silt, the machine was lost. No recovery vehicle in the Wehrmacht's inventory could move it. The High Command tried to bury the failure with a name change. They added a whole machine gun and called it the Elephant. New paint, minor tweaks, but the physics remained unchanged. The machine was the same. While crews abandoned 65-ton Ferdinands in the Russian mud, a far more systemic disaster struck the heart of the Reich. This was not a failure of armor or engines. It was the collapse of the industrial rear. November 1943. Allied bombers leveled the Alket factory in Berlin. The halls that forged the Stug 3, the backbone of the Wehrmacht, turned into a graveyard of twisted steel. The numbers tell the story of the impact. In October, Alket delivered 255 units. By December, that figure cratered to just 24. How do you compensate for the loss of the country's main factory? You put a proven casemate on a foreign chassis. The front was losing dozens of machines every day. Without the Stug, the German line was effectively naked. Engineers scrambled for a hybrid. They took the entire upper superstructure of the Stug 3 and welded it onto the hull of the Panzer IV. Krupp was already mass-producing those hulls. The assembly lines pivoted in a panic. The result was the Stug 4. It was never a part of a long-term strategic vision. It was a mechanical emergency, a parasite born from a bombing raid. Strategy did not dictate this design. Survival did. By the end of the conflict, the industry would churn out over 1,100 of these makeshift machines. The tank stayed the same, but the footprint changed. The Stug 4 is instantly recognizable by its Panzer IV heritage. It has 8 road wheels per side instead of 6. Engineers designed the Jagdpanzer IV as a calculated evolution, not a desperate field modification. It lacked the political baggage of the Ferdinand and the frantic origins of the Stug 4. This was a purpose-built tank killer on a Panzer IV chassis. It distilled 2 years of combat failures, from the Martyr to the Nashorn, into a single, lethal profile. The machine stood only 1.85 meters tall. In a concealed trench, the crew felt untouchable. The horizon loomed just above the low-slung roof. It was a ghost on the battlefield. But the interior remained a cramped metal box. The design was perfect. The logistics were not. Planners intended to arm it with the 75mm L-70 gun. It was the Panther's primary weapon. But the Panther program consumed every barrel coming off the assembly lines. The Jagdpanzer IV was left starving. How do you arm a hunter without its primary weapon? You cannibalize the past. The first units rolled out with the shorter Stug 3 guns instead. It was a placeholder for a future that never arrived. Hitler became obsessed with the low-profile design. He ordered a total halt to Panzer IV tank production to shift every chassis to the Jagdpanzer program. The generals intervened. They fought to save the only reliable turreted tank left in the German arsenal. They eventually convinced Hitler to maintain the balance. 2,000 units of all variants eventually reached the front. Generals successfully argued against the total shutdown of the Panzer IV lines. The 2,000 units of the Panzer IV could not plug every gap. Engineers sought a more lethal synergy. They mated the lethal 88mm Pak 43 with the agile Panther chassis. The result was the Jagdpanther, a 70-ton Predator with a 50mm sloped side plate. It was the peak of the tank destroyer program. But the peak was a precipice. In June 1944, the Jagdpanther made its debut in Normandy. 3 machines lay in wait. A column of British Churchill tanks entered the kill zone. The German guns roared. In minutes, 14 Churchills were burning wrecks. It was a tactical masterpiece. Then the triumph curdled. 2 of the 3 Jagdpanthers never left the field. Not because of British shells. They simply stopped moving. The crew climbed out. They did not run. They reached for explosive charges. They placed them deep inside the pristine hull. A muffled blast gutted the finest armor in the Reich. They destroyed their own masterpiece to keep it from the enemy. This was the curse of the final drive. The Jagdpanther lacked a turret. To aim, the driver had to pivot the entire 60-ton hull. Steel teeth ground against steel. The sensory reality was a rhythmic, metallic shriek. Inside the gearbox, the final drive gears were shearing under the strain. One sharp turn too many, and the teeth snapped. The tank became a stationary bunker. Why did the world's best tank destroyer die by its own hand? The transmission was a glass heart in a chest of iron. The industry was suffocating. Berlin demanded 150 units every month. Allied bombers ensured that never happened. Shortages of high-grade alloys and constant raids on the factories crippled the lines. Instead of thousands, only 400 were built over an entire year. By January 1945, a handful finally reached the Eastern Front. It was a drop of oil in a sea of fire. Engineers eventually strengthened the gears for the final production run. It was a technical success and a strategic joke. The war ended before the new parts could reach the front in bulk. The production total halted at exactly 415 units. While the Jagdpanther crews were detonating their own machines over failed gears, the High Command's obsession with scale birthed a 72-ton Ghost. This was the Jagdtiger. It was not a tank. It was a mobile fortress built on the limits of physics. 72 tons. That is the mass of 2.5 American Sherman tanks compressed into a single hull. Why did it need such weight? The answer was the 12.8-centimeter Pak 44. This was a naval gun adapted for the mud. The barrel alone measured over 6 meters. It was so massive that the ammunition came in two separate pieces, the projectile and the propellant. Every shot required two loaders working in perfect synchronization. The result was devastating. At 1,000 meters, the shell punched through 200 millimeters of steel. No Allied tank in existence, or even on the drawing board, could survive a hit. But why did the vehicle have an external travel lock for the barrel? Vibration was the enemy. Without the lock, the sheer weight of the 6-meter tube would shatter the elevation gears during transit. The Maybach engine groaned. 690 horsepower, the same unit used for the 45-ton Panther, was now tasked with moving a mountain. The roar was deafening. The engine strained to the point of structural failure just to reach walking speed. The insanity peaked with the external lock. A crew member had to stand up and open the heavy hatch. He crawled onto the sloped armor while the engine screamed and the tracks ground into the dirt. He reached for the heavy metal clamp at the front of the hull. To fire the weapon, he had to manually unbolt the lock by hand. If an enemy appeared during a march, the most powerful gun of the war was a useless iron pipe until a soldier stepped out into the kill zone to unlock it. This manual lock and 72 tons of dead weight met reality on January 4, 1945. Operation Nordwind began. It was the combat debut of the heaviest armored vehicle in history. Vehicle number 134 moved through the tree line. A bazooka round struck the side. Then came the high-velocity shells from an American M36 tank destroyer. The impact shattered the thin hull plates. The crew died instantly. 250 millimeters of frontal steel meant nothing. The threat came from the flank. By late 1944, the veteran panzer crews were gone. They were buried in Russia or sitting in prisoner camps. The replacements were raw recruits. Most had never seen a Jagdtiger until their first mission. They lacked tactical training. They lacked nerves. A wall of armor is irrelevant if the driver turns the side to the enemy. Most of these men didn't know how to keep the front facing the fire. Panic took over. The mechanics failed faster than the men. If a Jagdtiger broke down, it stayed down. No recovery vehicle on Earth could tow 72 tons of seized metal under fire. The crews simply jumped out. They set the demolition charges and ran. Statistically, the enemy was the least of their problems. 80% of all losses came from mechanical failure, empty fuel tanks, or simple abandonment. For every one Jagdtiger destroyed by Allied guns, The Germans blew up 4 of their own, while 80% of the heaviest Jagdtigers were self-detonated by their own crews due to mechanical failures. German industry made a final, desperate pivot. The era of the 72-ton monster was dead. The era of the 16-ton tin can had begun. This was the Jagdpanzer 38, universally known as the Hetzer. It was the antithesis of everything that came before. Small, cheap, simple. The origin of the Hetzer mirrors the same crisis that birthed the first improvised tank destroyers in 1940. Allied bombing raids obliterated the heavy factories. German engineers needed a vehicle they could actually build, not just design. They returned to the reliable Czech Panzer 38T chassis. They ditched the open-topped Martyr design for a fully enclosed, sloped hull. They fitted the same 75mm gun used on the Stug III. Inside, the reality was grim. The Hetzer stood only 2.1 meters tall. 4 men were crammed in a single row along the left side of the hull. Space was non-existent. With every shot, the loader and commander worked elbows to ribs in a suffocating steel box. The air grew thick with cordite and sweat. The ceiling was so low, a tall man couldn't sit upright. The math of the Hetzer was a brutal compromise. 60 millimeters of frontal armor, sloped at 60 degrees. Respectable from the front. But the sides were a mere 20 millimeters thick. One hit from a standard Allied anti-tank rifle or a light autocannon would punch straight through. It wasn't built to survive a duel. It was built to hide in a bush, fire one lethal shot, and disappear. By the final months of 1945, the Hetzer was the most important tank destroyer in the Wehrmacht. Not because of its specifications, because of its volume. In a war of attrition, numbers outweighed engineering perfection. The grand arc of German armor had come full circle. It started with a Czech gun bolted to an obsolete chassis and ended the exact same way. They sent whatever was left. The final orders were signed. The factories produced 1,577 units.